Welcome everyone. In this lecture, I will be explaining what is action potential. I'll give an example of some excitable cells like nerve cells. See, consider this is a nerve cell and this is a nerve fiber. So this function of the nerve fiber is to carry the impulses either from the central nervous system towards the peripheral organ or muscles in this direction, or from the periphery, that is from the receptor level, the signals are carried towards the central nervous system by the nerve fibers. So what are these signals? These signals which are transmitted from the nerve fibers are electrical impulses. And in medical term, these electrical impulses are called action potentials. So the signals are generated at one end of the nerve fiber. The signal generated at one end of the nerve fiber will propagate along the length of the nerve fiber to reach the central nervous system. In case of sensory nerve fibers, if this nerve fiber is a motor nerve fiber, the signals generated from the central nervous system end of the nerve fiber will be propagated towards the end of the nerve fiber, and this will send the signals to the effector muscles. So this is a motor signal. The sensory and motor signals are examples for action potentials. Now let me see how action potential is generated over the cell membrane of the excitable tissues. So consider this is a cell membrane. So when you place two electrodes on either side of the cell membrane and connect it to a galvanometer, before the application of stimulus, when there is no stimulus, there is a deflection of minus 70 millivolt across the cell membrane. This we call it as resting membrane potential for the neuron cell membrane, and this potential difference exists across the cell membrane with negative interior when compared to positivity at rest, that is before the application of the stimulus. So when this cell membrane of the axon or nerve fiber is stimulated with a threshold stimulus, this is very important. So when the membrane is excited or stimulated with a threshold stimulus, that means the threshold stimulus should be of an adequate strength and adequate duration. So when this threshold stimulus is applied to the cell membrane permeability for sodium ions increases. So lot of sodium ions start entering into the cell, so bringing the positive charge into the cell. So initially the potential difference was minus 70 millivolt at rest. Now because of the threshold stimulus, the potential difference becomes more positive inside the cell. So from minus 70 it can go up to minus 60 or minus 55 millivolt. So with the entry of positive charge, the potential difference is becoming less negative, or it is going towards positive side. So this is because of the threshold stimulus altering the membrane permeability for sodium. So initially at rest, the potassium permeability for membrane is more than the sodium. So there was a continuous leakage of potassium at rest, taking out the positive charge outside and making the membrane potential negative. That was minus 70 millivolt. Now with the electrical stimulus, the membrane permeability of the sodium will become more than that of the potassium, around 500 to 5000 times more permeability for the sodium when threshold stimulus is applied. So what happens? The membrane potential from its resting state, minus 70 millivolt, it moves to positive side, that is it becomes minus 55 millivolt because of the entry of sodium ions through the sodium leaky channels. See, consider this is because of entry of efflux of sodium ions along the concentration gradient through the sodium leaky ion channels. This is not voltage gated sodium ion channel, remember it. This is through sodium conductance through sodium leak channels. So from minus 70 to minus 55, the membrane potential is altered. So this is a slight depolarizing potential, and this potential at which minus 55 millivolt is present across the cell membrane is the firing level. Firing level. So at this level, what is happening? When the membrane potential reaches minus 55 millivolt, when the membrane potential from minus 70 millivolt is changed to minus 55 millivolt because of influx of sodium ions through leaky sodium channels, at minus 55 millivolt, what is happening? Lot of voltage gated sodium channels, voltage gated sodium channels starts open up, their gates open, and there is rapid influx of sodium ions into the cell, bringing the positivity inside. So this is like flooding of sodium ions, sodium flooding. So because of rapid opening of large number of voltage gated sodium ion channels along the concentration gradient, sodium will start entering into the cell from the extracellular fluid, increasing positivity within the cell, so that the membrane potential, which was at minus 55, will become more and more positive. It goes on becoming positive. It can overshoot the zero, it can go up to plus 30 millivolt. So this increase in membrane potential towards positivity from minus 55 firing level to plus 30 millivolt is because of rapid influx of large amount of sodium ions through activated voltage gated sodium ion channels. So by the time the membrane potential reaches plus 30 millivolt, these voltage gated sodium ion channels become inactive. The voltage gated sodium channels become inactive, so that there is no further influx of sodium ions. So it stops at plus 30. Inactivation of voltage gated sodium ion channels happens, and at the same time there will be activation of voltage gated potassium channels. The voltage gated potassium channel gates open up, so that potassium along the concentration from the interior, it can move out of the cell. We call it as potassium efflux. So taking out the positivity from the cell, so outside becomes positive, inside becomes negative, so that from the plus 30 millivolt, the membrane potential will return back to its resting levels, that is around minus 70 millivolt, because of continuous efflux of positive charged potassium ions, taking out positive outside, and the inside becomes negative. So restoration of polarized state is happening. So this is called as repolarization. Restoration of polarized state is repolarization, that is happening because of the activation of voltage gated potassium channels and potassium efflux along the concentration gradient. But this voltage gated potassium channels will remain open even for a longer duration, so that the potassium efflux continues for more duration, so that what is happening, the positivity charge is moving more and more out, so that the negativity inside the cell will become more and more negative, even more than that of the resting state. So it can become more negative. So compared to the resting state, it can become more negative, like minus 75 millivolt. So this portion, we call it as hyperpolarization. This hyperpolarization is increased negative potentials more than that of the resting level potential is hyperpolarizing potential. And what is the reason for this hyperpolarizing potential is continued slow efflux of potassium channels through the voltage gated potassium channels. Continued efflux of potassium ions through voltage gated potassium channels. So what you can understand here is, from the resting level minus 70 millivolt, there is leakage of current, that is leakage of positive charge sodium ions through leaky sodium channels, so that the resting membrane potential from minus 70 is taken to minus 55 millivolt, that is the threshold potential, because of entry of positive charge. From minus 70 it is going to minus 55 millivolt. So at this firing level, at this threshold potential, we call it as threshold potential, at this threshold potential, what is happening? Large number of voltage gated sodium ion channels are getting activated in that area of the cell membrane. In that area of the cell membrane, large number of voltage gated sodium ion channels are getting activated, so that rapid influx of more and more more positive charge into the cell, rapid influx of positivity. That's how the membrane potential from threshold level minus 55 is taken more than 0. It can reach up to 30 millivolt because of the rapid influx of positive charge, and this increase in the potential is depolarization. So from minus 55 millivolt to plus 30, you call it as depolarization. So deviation from the polarized state. The polarized state is the resting state, that is the negative state. So depolarization is the positive state within the cell. Within the cell, the positive state is because of the influx of sodium ions along the voltage gated sodium ion channels. So at plus 30 millivolt, there is inactivation of sodium ion channels, that is closure of sodium ion channels, so that there is no further influx of sodium, and at the simultaneously there is activation of potassium ion channels. So potassium starts going out of the cell, taking out positive to the exterior. The inside becomes negative, 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 so that from positive potential it comes to the negative resting potentials, that is restoration of negative potential. We call it as repolarization. Repolarization is restoration of negative potentials from the positive plus 30 millivolt towards the minus 70, and there is a continued efflux of positive charge, and inside becomes still further more and more negative compared to resting state. It becomes further more and more negative, that we call it as hyperpolarization. Increased further negativity is hyperpolarization. This is because of potassium channels will remain open for longer duration, and there is continuous potassium efflux through the voltage gated potassium ion channels, and only at this hyperpolarized point there is inactivation of potassium channels, and slowly the membrane potential from minus 75 is restored back to its resting state. And at this point, the sodium potassium ATPase pump acts in order to pump out the sodium ions and pump in the potassium ions, maintaining the concentration of sodium ion exterior more, and to restore back the lost potassium from the interior of the cell. So what is happening here? During depolarization, lot of sodium has entered in. The concentration within the cell sodium is increased. During repolarization, a lot of potassium has gone out. The concentration within the extracellular fluid potassium concentration is increased. But as we all know, this potassium concentration should be restored. The potassium concentration should be more within the cell, and this is restored by the action of sodium potassium ATPase pump. So this is all about action potential. So action potential is nothing but brief sequential changes in the membrane potential from the resting membrane potential. So rapid depolarization, rapid repolarization, followed by slow repolarization, followed by hyperpolarization. These are the different phases of action potential. So in general terms, action potentials are nothing but the signals. So this action potential is brief sequence of change in the membrane potentials that is happening over the cell membrane of excitable cells. So one of the example for the excitable cell is a nerve cell. So over the cell membrane of the nerve cell, initially inside the cell membrane, inside the cell it is negative, outside the cell is positive. This is the resting state with minus 70 millivolt. Because of the threshold stimulus, action potential is generated. So because of generation of action potential, what is happening? There is depolarization graph, repolarization, hyperpolarization, and resting, bringing back to resting state. So this is an action potential graph that is generated over the cell membrane, and this action potential is nothing but the electrical impulse that is generated over the cell membrane. So this electrical impulse that is generated over one point or a point of stimulus, threshold stimulus, this electrical impulse have to propagate to the neighboring area of the cell membrane. From this neighboring area, it has to propagate to the next neighboring area. From here, it has to propagate to the next neighboring area. And this is how the electrical impulse has to transmit from one region to the other region throughout the length of the axon till it reaches the nerve terminal, and finally exciting the next neuron. So this is how the action potential propagates. So there is a property for action potential, that is propagation. So there are two types of propagation of action potentials that we'll discuss in the subsequent classes. So in the properties of action potential. So to summarize, what is action potential? Action potential is a brief, rapid, sequential changes in the membrane potential from its resting level towards a plus 30 or overshooting level and restoring back to the resting level. So these sequential changes that is happening within the cell membrane potential with the application of threshold stimulus is action potential. So when a stimulus that is equivalent to threshold or supra-threshold stimulus is applied, then only the action potential is generated. If the threshold is less than the if the stimulus is less than the threshold stimulus, there won't be generation of action potentials. But what is generated with the sub-threshold stimulus? Yes, graded potentials or local potentials are generated. So with slight sub-threshold stimulus, what is happening? There is a certain distortion in the cell membrane. The membrane permeability for sodium will get more than that of potassium and slight leakage of positive charge. So there can be a slight depolarizing potential, but this will not reach to the firing level. So from minus 70 it can go up to minus 60, but not reaching the minus 55 millivolt firing level. It will not reach the minus 55 millivolt. So this is called a local potential or graded potential because of the sub-threshold stimulus, and this will not generate the action potentials. So only when the membrane potential is taken from minus 70 millivolt to the firing level because of influx of more and more positive charges, and when the membrane potential reaches the firing level, then only there is generation of action potential. You must know that. So in the next class we'll discuss about what are the different properties of action potentials. So you understood the different phases of action potential. Action potential includes from the resting state, the slight depolarizing potential, which is because of the leakage of current, positive charge, and from the firing level there is a rapid depolarization because of activation of voltage gated sodium ion channels, and at plus 30 millivolt there is inactivation of voltage gated sodium ion channels and activation of voltage gated potassium channel. So there is potassium efflux, and from plus 30, because of the continuous potassium efflux, the membrane potential will return back to the resting level, and even from the resting level it can reach more and more further negative, that is hyperpolarization because of the continuous potassium efflux. Thank you.